Now we start another definition of a binary operation. The binary operation start on a set capital A said to be commutative if A star B is equal to B star A for all A B belongs to capital A, and also associative if A star B star C is equal to A star B star C for all A B C belongs to capital A. Okay. Example: show that addition on the set of a real number, multiplication on the set of a real number are commutative binary operation, but subtraction and division on the set of a real number are not commutative. Let A B belongs to R and A less than B not equal to 0. Then A plus B is equal to B plus A belongs to R. A into B equal to B into A belongs to R. But A minus B not equal to B minus A. A by B not equal to B by A. That means if we take any two real number, then their addition are commutative, multiplication are commutative, whereas we see subtraction and division are not commutative. Suppose 3 5 belongs to R. 3 plus 5 equal to 5 plus 3, that equal to 8 belongs to R. 3 into 5 is equal to 5 into 3 is equal to 15 belongs to R. But 3 minus 5 is equal to minus 2, and 5 minus 3 is equal to 2. That minus 2 not equal to 2. So 3 minus 5 is not equal to 5 minus 3. Similarly, 3 divided by 5 belongs to R, and 5 by 3 belongs to R. 3 by 5 not equal to 5 by 3. Okay, next another definition. Let's start definition. Let's start is a binary operation. A binary operation on a set A, capital A. Then first the set A, set capital A is said to have an identity element if there exists a unique element, if there exists a unique element E belongs to capital A such that A star E, A binary operation with E equal to E star A equal to A for all A belongs to capital A. For all A belongs to capital A. In that case E called the identity element. In that case E is called the identity element, identity element with respect to the binary operation star. That means on the set A, star is a binary operation. The set A is said to have an identity element. The set A is said to have an identity element if there exists a unity element E belongs to capital A such that A star E is equal to E star A that equal to A for all A belongs to capital A. In that case, E is called the identity element with respect to the binary operation star. Okay? Next, if the set A and if the set capital A has an identity element if the set A has an identity element means there exists an element E such that A star E is equal to E star A equal to A. If the set A has an identity element A belongs to has an identity element E has an identity element E with respect to the binary operation star binary operation star then an element A belongs to capital A is said to have an inverse with elements with respect to binary operation star denoted by a to the power minus 1 if A star A inverse star A is equal to E. In that case, A inverse by A to the power minus 1 is called the inverse of A with respect to the binary operation star with respect to the binary operation star. Second inverse definition: if the set capital A has an identity element E, if the set capital A has an identity element, that means if a set has an identity element, then there exists its inverse. If the set A has an identity element E with respect to the binary operation star, then an element A belongs to capital A. Then the element A belongs to capital A is said to have an inverse element with respect to binary operation star denoted by A to the power minus 1. That means if A is an element of A and if the identity element exists in the set A, then there exists is the inverse denoted by a to the power minus 1. If A star a binary operation with the A inverse star A equal to E. In that case, we say that A to the power minus 1 or A inverse is called the inverse of A with respect to the binary operation star. Now, we will take some examples. Example 1. Example 1. So that 0 is the identity. So that 0 is the identity for addition on capital R, and 1 is the identity for multiplication on R. Multiplication on R. But there is no identity element but there is no identity element for the operation subtraction and a division. Okay, that means we have to show that 0 is the identity element for the binary operation addition on the set of real number, and 1 is the identity element for the binary operation multiplication on the set of real number. But there is no identity element for the binary operation subtraction and division on the set of a real number. Solution. We know that 0 belongs to R and 1 belongs to R. A plus 0 is equal to 0 plus A, that equal to A, or all A belongs to R. A into 1 into A equal to A, or all A belongs to R. That means if A is any real number, then if we add A with 0, then we get that number A. If we multiply A with 1, then we also get A. So 0 and 1 are the identity elements of the binary operation addition and multiplication. So 0 and 1 are the identity elements for the operation for the binary operation addition and a multiplication on R, on the set of real number R. Now we have to show that there is no identity element for subtraction and a division. There is no element. There is no element E belongs to capital R such that A minus E equal to E minus A for all A belongs to R. That means there is no element in the set of a real number that we subtract from a real number. E subtract from real number are commutative. That means A minus E is equal to E minus A for all A belongs to R. Similarly, we cannot find any element E in a R plus positive real number. In a R plus such that A divided by E equal to E divided by A for all A belongs to R plus. For all A belongs to R plus. So subtraction and division do not have identity. Do not have identity element on the set of a real number and R plus positive real number respectively. Now we change it on, but there is no identity element for the operation subtraction and division on set of the real number and R plus respectively. Okay. Now take another example. Another example show that minus A is the inverse of A. Minus A is the inverse of A for the addition plus on capital R and 1 by A is the inverse of A not equal to 0 for the multiplication operation on R. Okay, addition operation. Multiplication operation. since we know a plus or minus a, if a is any real number, a plus of minus a equal to minus a plus of a equal to 0, equal to 0 for all a belongs to R, for all a belongs to R. So minus a is the inverse of a, inverse of a for addition operation, for addition on capital R, for addition on capital R. Similarly, for a not equal to 0 belongs to R, a into 1 by a equal to 1 by a into a equal to 1. For all a not equal to 0 belongs to R. Any real number that is not equal to 0 belongs to R. So 1 by a is the inverse of a, inverse of a not equal to 0 belongs to R for multiplication on capital R. Okay, thank you.